Thank you so much, Rob, for the introduction. And yeah, let's go for it today. So, as Rob introduced me, yeah, my name is Christian Beek. I'm based in the Netherlands. I've lived all over the world for my job, in the Middle East for a few years, in the US a few years. Learned a lot from all these cyber incidents in the regions and the politics going on. Um, while looking at the different things happening. And my current role actually is, I would say, like a perfect example of like different background experiences, like ethical hacking, forensics, malware analysis. And currently, I'm leading kind of a team of threat experts hunting for the latest threats. And at the same time, what we learn, what I see, what we observe from those, I would say, advanced threats or new developments. Uh, I go back to the engineers and the data scientists, and we stick our heads together and we try to understand, okay, what is happening? Do we have technology in place that is detecting this kind of new techniques we're observing? And if not, do we fine tune something or do we need to innovate here? So a lot of things which makes my daily job very exciting. And as well, I'm a big supporter of the No More Ransomware organization. So if you're hit by ransomware, you can go to this website, nomoreransom.org, and look if there's a free decryption tool for your specific case. And as well, I'm a big embracer of the MITRE ATT&CK framework. You will see some of that during this presentation as well, contributor. So there's tons of stuff I'm doing, and actually, I'm excited about today talking about YARA with a touch of science. Because honestly, I will take you on a little journey through again ransomware. I just heard Vitaly about his keynote, talked a little bit about ransomware as well, and actually, I'm going to take you in a little bit through a journey of ransomware history, but also I think that history will reflect also the way we started all in this industry writing YARA rules, and also how we actually evolved, and actually my experience, my learning experience over the years as well with YARA. So before we go into that, if you are not aware of this yet, we have from the ATR team, we have a GitHub page, and we frequently post actually YARA rules on this page. They're free, so please use them. Also, give us feedback if you think they're not properly working or there's some things. We do test them. We do test them against our sets, but we're human beings, so sometimes we can make a mistake. But if you want to, this is the link, and you can find a ton of rules there, as well as you can see a lot of YARA rules that we have around ransomware as well. So I'm actually currently working 9 years in McAfee, and I think it was like I think 6, 7 years ago when I moved to the US and I started to work in McAfee Labs to take on the position for Director of Threat Intel. Um, my chief came to me one day and he said, like, hey, there's a lot of calls coming in from customers getting hit by something called CryptoLocker, and this kind of ransomware. Can you have a look into this? And honestly, since then, ransomware never left my plate. So still on a daily basis, we're fighting ransomware. And what you can see here in this picture, I just made a few highlights here. The above diagram is about like how many unique ransomware samples and families are we seeing every month during the last couple of years. And of course, a big family, of course, was CryptoWall back in 2014. And you see actually in 2015, like March, we have like the first ransomware as a service. So you don't need to be very smart, just have a bag of money, and you can buy yourself into an affiliate campaign. You have to distribute the ransomware, but you're not responsible for writing the code. Another thing we saw popping up, which was I think a big spike for multiple families we saw later on, was like hidden tier. The guy posted on GitHub and it said like for education purposes only, but unfortunately a lot of people didn't use it for education purposes only, but actually started to use it as a base of their code to really shoot out ransomware en masse. Now, if you look further down the line, we see in January 2017, February, the attacks on the hospital started. Like really, instead of like what I called the spray and pray they pay attacks, which is copyrighted by myself, just joking. But really, it was really the first time it was about like, okay, let's send out 10,000 emails or use exploit kits and hope that people are hitting the button or click the link and start getting infected, and hopefully they will pay. That really, that it's still happening with some of the families. Like we suspect at the moment that the snake ransomware, for example, is one of those cases where it's spread by email as an attachment. But if you look, for example, from February on, more and more the attacks are starting to get targeted. It started with some hospitals, healthcare, some others, and now, which Vitaly highlighted in his keynote as well, we see it's no longer the targeted ransomware attack, but they also are stealing the data. And if you don't pay, they will leak your data. And in some cases, they actually even auction your data. So you really see the trend is really shifting again, like for a more focused, targeted attack. And if you would analyze more like what are the top sectors that are being targeted, I would say from our statistics in our team, we see that manufacturing is really the number one sector that's being targeted by different ransomware families at the moment, and actually try to extort a lot of money from these victims. And if you look back from CryptoWall till now, uh, back in the days, in 2014 and before, I already started to use some YARA, and actually one of the questions I just answered on the forum is about, can you use YARA for memory? Yes, of course, you can use volatility with the YARA scan plugin, and you can use your YARA rules. And it's actually those were the times where I started to play with that for ransomware, and I had to dig uh, back into one of my archives. But actually, this was actually one of the first rules I wrote for like CryptoWall. And as you can see in the strings, since the PE module was not in YARA yet, I started to write like the MZ header, and I did some of the strings and with the PDB path. And well, the condition was like, hey, the MZ should be there at the first position, and one of the strings, and that will identify CryptoWall. Well, CryptoWall started to evolve, and actually we went to CryptoWall 1, we went to CryptoWall 2 and 3. So very quickly, actually, this rule was no longer working. So we need to think about something else. And actually, that's where I used, for example, a memory rule where I said, I was like, hey, I see some pattern coming back in memory every time when CryptoWall is being executed. Is there a way we can write a YARA rule for memory? So we did, but unfortunately at the time, and not a lot of, I would say, products, commercial products, were actually supporting YARA scanning memory. So, but it was already the time where I started to experiment and see, like, look, we're looking at maybe a single sample, which is not very often changing. But what if they change? Is there something we can automate, or is there something around patterns we can look at actually to discover this more? And honestly, a rule like this, or it's maybe like 5-6 years old. If you are in an incident response case and you need a quick rule, by all means, if you do it like this with a few strings, which we will identify your sample, just do it. I did once for like NotPetya, which it hit the environments over here, and we got a sample and quickly like, hey, there's a few unique strings in it, and we did the header and some other things and the size, and honestly, within 10 minutes, we had a quick and dirty rule, but it was for that first 12 hours enough to stop the bleeding for a lot of companies. And later we fine-tuned it to a far more better rule. But if you are in an incident response case and you have to write a quick and dirty rule, stuff like this will work for a time. So what are some of the tools I'm using? So to write YARA rules, there's different ton of stuff you can do, and there's a lot of things you can use as well. But for me, just a simple strings command with on the command line with the output, the PE Studio. There's a a GUI version of it, but also on GitHub there's a command line edition of it. And especially if you are analyzing multiple samples from the same family, for example, or you have like a specific threat actor and you want to analyze a set of their tools, if they might use some same subroutines, or they might want to use the similar kind of code for network identification. If you look, for example, to Hidden Cobra, they have a specific way of writing certain network communication modules, and you see that coming back over several of their malware families. That's where I put in something like a PE studio, for example, for some quick and dirty stuff. But of course, VirusTotal for hunting, but also I'm using IDA, IDA Pro, and Radar. And one of the things I use a lot as well for going over analysis of data is the Jupyter Notebooks. So writing some Perl code that will actually go over the data and the output that give me the statistics and analytics which I need to improve my YARA rules. So there's already your bit of science, but I will highlight a little bit more further on the presentations. And when I'm really lazy, I need a quick and dirty rule. I use this fantastic tool that was written by Florian Roth. It's called YARA. It will automatically generate a YARA rule based on a few samples, and you can use it with an opcode tag to include the opcode as well. And I saw one of the questions and Vitaly answered as well, like generating automated rules. I think there is a place for those tools if you are in a hurry. But again, if you look at the outputs, you need some experience to look at the output of a rule. Like if the rule is created, you really need to verify, like, hey, are some of the strings are useful, or are these strings like, hey, this will generate a lot of false positives? And honestly, that's also a matter of experience you need to have. Another thing I love to do as well is using visual inspection. So, for example, if I have, let's take, for example, Sodinikibi ransomware, if they come up with a new version, there's multiple versions of them. I probably load in like 1, 2, 3 different versions of that ransomware family. And I start to look quickly with a visual inspection, like 2D and 3D. If there's any differences. And as you can see here, maybe it's a bit difficult to see, but if you look at this particular sample, the one is from 2019. I think it was like October or something like that. And the one on the right here is, I think like March, May 2020. You can see the first start of the ransomware. If you look at the green, the 2D visualizations, you see like the headers are almost the same. Like you see the sequences over there visually are almost the same, but down the bottom you see definitely there are differences in this code. And then it's interesting to see, like, okay, if I do this visual inspection, all right, so probably if I want to write a YARA rule, the optical visual parts, and with this tool, you can actually look at the offset of where this is happening. That's perfectly to go to your IDA, for example, and look at the same offset and see, like, okay, what is the same? What has changed? And that is a quick way to look for, okay, which parts are unique and which parts are always the same, constant, and it will help you to write your YARA rule, for example. So if you look then, for example, as a recent YARA rule for Netwalker, actually, Vitaly did, and I didn't talk about like our talks, but it was fun that he was mentioning Netwalker as well. And if you look at this YARA rule over here, you can see I'm using here as well some code strings where I said, like, hey, these are some of the unique parts where we're seeing in Netwalker, which is equal to, for example, a sample 3 months ago, then a sample we saw like maybe yesterday. And one other thing I would like to give you as a nice tip is, like, if you're going to use YARA rules, one really great way to track progress or to track some of your adversaries or families, what is happening in your network, is to use metadata. So as you can see here, highlighted in my red square, what I try to do is here is to say like, hey, what is the malware type we're hitting here? Okay, it's ransomware. Which MITRE attack techniques is it using? Okay, these three attacks. Which actor type? Well, it's cybercrime. And if there was an actor known, well, in this case we don't know, but if there was like a nation state, you could have put here hidden cobra or something else. But the great thing is if you do like hunting on samples and you use the YARA -M and of course the other highlights, it will output the metadata in the results. So if you export that, for example, your output to a database, and you can actually load it up into Elasticsearch Kibana, you can really create some nice visualizations. So you can actually say like, hey, this month we have seen this type of malware with this family name, with these MITRE attack techniques in my network. And if I see all those MITRE attack techniques, which ones are it, and which technical solutions in my network should be able to detect and stop these techniques being used by these malware families. So it's a lot. It's actually a very easy way, but also a great way to create visibility about what is happening, but also correlate and give you information that might help you to steer a direction of your protection and your countermeasures. And as you can see in the bottom, well, since the PE module it was now available in my for YARA, I no longer have to put in like the MZ header string. So definitely I could use the condition like uint with the PE header and any of the code strings that would identify this network or ransomware sample. Another thing I love to do as well is like if you look at the previous rule where I have a lot of this metadata and I have the strings here, another thing you can do, and it's really about if you like the style or not, is actually using private rules. So the private rules you won't get the results from, but it's actually some of the things you can build in. So you can write really compact YARA rules. And in this example, what I show you here is like we do the import PE, and I do a private rule for the PE check. So where the condition is like either one of two, and I really check for payload 1, or I check for payload 3. Payload 2. And as you can see, my whole rule now at Crime Ransom Networker is condition, PE check, and payload 1 or payload 2. So that's a different way of writing rules. But honestly, if you have like a nation state threat actor and you want to write specific rules for them with different payloads, for example, if you look at the hidden cobra stuff, I have a rule where I do the same, like where I have a private rule for the PE check. I have a couple of payload private rules, and then I say like, look, if it's family A, it should be payload 1 or 2. If it's family B, it should be payload X, Y, and Z. It's a way of how you can write YARA rules, and just an idea for you to maybe experiment with the syntax. Now, looking into ransomware, like, and as I mentioned before, for being more than 7 years working on ransomware, it's easy to actually it's you need to understand what is happening and what are the different components we see happening in ransomware. So of course it has an encryption mechanism, it has a lot of file interaction, a lot of the files ransomware samples itself, some of their sections have a high entropy, so a lot of characteristics can be discovered if you look at ransomware. And if you divide it over API calls and their functions, which I love to do, this is a way how I look at malware. So I look at, okay, registry operations, which API calls are involved, file operations, which API keys are involved, and so on. And this is in generic for malware, but for ransomware, for example, the file operation and I would say is very key. The process and threat operation. A lot of the ransomware families do like a process injection kind of technique. So those API calls involved are very interesting. So what we did, and thank you, Mark, if you're on the call, for helping me out with this. So we gathered like a unique data set of 1,000 unique ransomware families. And what we started to do is actually first we started with an Excel sheet, right? You take like 5 families, you extract the data from the API calls, and you see like, okay, is there some kind of overlap? Is there something in my experiment that would this work? And actually, if you look at ransomware family A till G, you will see in the colors that there are some API calls that will come back in almost every family, like to find first, to find next. That's the loop what they are using for encrypting of your files. So find the first file, okay, encrypt it, okay, extension after the file, okay, right, completed, next file. So this is how they are actually looping all the time. But also the find close, we had to get the module file names. So more and more of these API calls were getting back into our data set. And so the first 5 families, it looked promising, but of course, you can't compare 1,000 unique malware families using output and Excel sheet. So we wrote the Jupyter Notebook where we said like, okay, if I have several API calls and I have several ransomware families, and honestly, for the sake of making this more visual than showcasing you 1,000 malware families with all the API calls, I just highlighted here one or two. So yes, you can see the get current process ID, get the module file name, the crypto agency constants. Those were some of the API calls that were coming back over and over again in several ransomware families. And by doing this, you can generate some really nice statistics, like and highlighting like, hey, which of the API calls, for example, are scored the most highly and which ones are scored low. So by doing that, actually, we were able to create a kind of model around like, hey, for ransomware, like I want to hunt for ransomware samples. Is there a way I can automate this? And if so, can I create a kind of hunting rule that will cover a lot of families? Because honestly, if you create a generic YARA rule for hunting for ransomware, and what I saw in the beginning, a lot of people were hunting for the ransom node. So like your files are being encrypted. Well, that worked maybe for a few months, but it won't cover for, I would say, the latest ransomware families. So combining it all, where you have these private rules, where you have some of the metadata, but also what we learned from the API calls, we started to combine this all together in YARA Rules. And so what I actually do is, for example, I have to, of course, the import modules, the PE, but also if you love to experiment, the math module has some really nice functions as well to use. Then I combine my rules with private rules, so the PE header or file type, because what I want to do, like I want to really be specific on what I want to look for. Sometimes, if a ransomware adversary is using a specific way of doing a MITRE attack technique. So, for example, let's take process injection. Some ransomware families stick to this specific and particular way of injecting ransomware. I will put that technique into a private rule. And then actually what I did is actually create a section with the API calls and typical strings with a value based on what we learned. And at the end, I will do like the condition where private and conditions are around values and scoring. So to give you a little example here is, for example, I left out the private parts here, like the import, the PE header and stuff like that. But what you see here, for example, is like, hey, the API get last error has a weight of 3.54. And the sleep command API has a weight of 3.53. And as you can see in my condition when I build it up, each string and actually the value will be multiplied. It will end up with the value. And if that certain value will trespass a certain score, either it will be ransomware or it might be some other malicious thing. So this is how we currently are experimenting, and myself are experimenting with YARA rules to actually put a kind of machine learning into the rules and to create a more generic hunting rule for, in this case, ransomware. But you can actually apply this the same for if you want to hunt for a specific family, you can do the same. But it's an interesting process, and I'm still fine-tuning about it. But I really like the results I've seen so far, and it's pretty cool to do. So with that being shared, I will open up the floor for questions, Rob.
Thank you, Christian. So the first question, and this is quite a tough question, actually. So with respect to paying ransom, at what point does it become necessary to not pay? That everyone should just stop paying the ransom?
It's a really good question, and I will try to answer it in two ways. So I would say, as an industry, we have been shouting out always like, do not pay, right? And we have proven at some point, for example, with when we researched the financial streams of Sodinikibi, that not only you pay the ransomware actors, you keep the model alive. And at the same time, we saw that the ransomware actors were actually buying drugs and other stuff on underground markets. So it was not only supporting the ransom model itself, but it was also supporting more crime-related operations. Now, if you look at, for example, let's take a hospital or manufacturing, which I mentioned are the number one sectors at the moment. It makes sense. Why are they targeting those industries? The reason is, like, if you look at the CIA triangle: confidentiality, integrity, availability. I would say confidentiality and integrity are the most important ones for most companies in the world. Where I would say, like, manufacturing and healthcare, availability is the number one. So 24/7, 365, people need to be healed, right? There needs to be healthcare. Or in manufacturing cases, we need to produce cars 24/7. So I can imagine that if you are hit as a hospital and you get asked, let's say, $50,000 and to pay, or you are down for at least a week to restore from backups, I can understand why sometimes people decide to pay the ransom. But still, it's never a guarantee that you actually will receive the right decryptor, yes or no. I hope this will answer the question for the person.
I think so. So thank you, Christian.